right, welcome back to the deep dive. Today we're going to be looking into something that sounds pretty complex, at least at first. Data abstraction.
Sounds very techy.
It does, right. But, at its core, data abstraction is all about simplifying things. And honestly, we do it all the time without even realizing it.
I think I know where you're going with this.
Yeah.
Imagine using your phone, right, to take a photo. You just, you open the app, you frame the shot, you press a button, boom, you've got a picture.
Exactly.
But behind the scenes, there's so much going on.
A ton.
There's like intricate hardware, camera sensors, image processing algorithms, storage mechanisms, like a whole bunch of stuff you don't even have to think about.
Right. And that's data abstraction. It's just hiding all that complex stuff away so you can just focus on taking the picture.
Totally. You're interacting with this simple interface without needing to know all the nitty-gritty details.
And that's what makes it so powerful, especially for learning.
Right.
We can grasp these really complex concepts without feeling completely overwhelmed by all the details.
It's like you see the controls you need, the interface, and the underlying complexity is like tucked away so you can just achieve what you want to do efficiently.
Exactly. And in the world of Java programming, we achieve this data abstraction through some really cool mechanisms. And one of the most important ones, the one we're going to really dig into today, is interfaces.
Interfaces. The heart and soul of abstraction in Java, arguably.
Now, before we jump into interfaces, for those of you who've been following our deep dives on object-oriented programming, remember all those concepts we've discussed.
Oh, you mean like classes, objects, encapsulation, polymorphism, and inheritance?
Exactly. All that stuff. It's all going to come into play as we unravel this whole interface.
It all builds up, right? Like a foundation.
Absolutely. So this data abstraction thing, it's all about showing what's essential and hiding all those implementation details. And it's super important for good object-oriented design.
It's like the cornerstone.
And in Java, the main ways we achieve this are through, well, two things: abstract classes and interfaces.
The dynamic duo.
And today we're focusing on interfaces.
Why interfaces, you might ask?
Well, because according to our sources, they offer, get this, 100% abstraction.
That's a pretty bold claim.
Oh,
100% abstraction.
All right.
So like if abstract classes give you some level of hiding things, interfaces take it to the max.
Yeah, pretty much. And they're also, according to our sources, generally the preferred tool in real-world development.
Makes sense.
For creating those flexible and robust systems we all love.
It's that phone camera analogy again. Remember, you don't see the internal circuits or code when you take a picture. That's the level of like encapsulation and hiding that interfaces aim for.
Right, right. So, okay, 100% abstraction sounds pretty powerful, but what exactly is an interface in Java?
Yeah, good question. At its heart, an interface is often described as a blueprint of a class. Now, blueprint might sound a bit abstract.
Yeah, say it's already abstract.
Yeah, right?
So how do we even...
But just think of it like design specifications for, let's say, a remote control.
Okay, I like that.
So the specifications, they outline what the remote must be able to do, like change the channel, adjust the volume, power the device on or off,
The essentials.
Exactly. But it doesn't say exactly how each button press actually makes those things happen inside the remote.
It's like the what, not the how.
Exactly. And similarly, a Java interface, it defines a contract. It basically dictates what a class that implements this interface must be capable of doing.
So it's like a set of mandatory capabilities.
Yeah, that's a good way to put it.
Yeah.
And you'll even see a similarity in how you define them in the code.
Oh.
Just as you use the class keyword followed by a name to create a class, you use the interface keyword followed by a name to define an interface.
Okay.
And just like classes, interfaces can contain variables and methods.
All right, so blueprint, variables, and methods. Got it.
But, of course, there are some big differences compared to regular classes.
I imagine so.
Let's start with variables.
Okay.
The main rule for variables in interfaces is that they can only be final and static.
Final and static. All right. And just to make sure we're all on the same page, what do those mean again?
Right. Good point. As a quick recap, final means that once you give a variable a value, that value can't be changed. It's fixed. It's a constant.
Like set in stone.
Totally. And static, it means the variable belongs to the interface itself, not to any specific object of a class that, implements the interface. It's shared.
Shared across all the classes that use that interface.
Exactly. And here's the thing. In an interface, those keywords, final and static, they're applied automatically.
Automatically?
Yeah, so even if you don't explicitly write final or static when you declare a variable in an interface, Java just treats it as if you did.
Oh, that's interesting.
It is. And this restriction to constants and shared values, it really emphasizes the role of interfaces as defining behavior, right? Not holding data that can change.
Right, right. So any variable in an interface is basically a constant that all the implementing classes can access.
Exactly. It's efficient.
Now, what about methods within an interface? I know there were some interesting changes over time in how interfaces handle those.
Yeah, there's been an evolution for sure. Before Java 8, interfaces were pretty strict about methods. They could only have abstract methods.
Abstract methods. Can you give a quick refresher on what those are?
Of course, an abstract method is like a task title and outline, but without the actual instructions.
So it's like, do this, but not here's how to do it.
Precisely. It has a declaration that specifies, the return type, the method name, any parameters it needs, but it doesn't have a body, like the actual code to execute the task.
Oh, I see. So the interface is basically saying, hey, this capability needs to exist, but it's up to the classes implementing the interface to figure out the how.
Exactly. That's how you hide the implementation details. The what is defined, the how is left open. But like I said, things changed in Java 8. That's when they introduced default methods and static methods.
So that means interfaces could now have methods with actual implementation.
In a way, yeah, default methods, they were introduced so you could add new functionality to existing interfaces without breaking all the classes that were already using them. It's like a default implementation that classes can use as is or override if they need to do something different.
Makes sense.
And static methods in interfaces, they're more like utility functions that kind of logically belong with the interface itself.
So even with these new types of methods, the core purpose of abstract methods remains, right? Like defining the contract.
Oh, absolutely. Interfaces still primarily define what needs to happen through those abstract methods. The implementing classes still figure out the how. That separation is like super important for data abstraction and building systems that can change and adapt easily.
Okay, so interfaces, contracts, abstract methods. Got it. Now, I remember our source mentioned something specific about the access modifier for methods and interfaces. They're implicitly public, right? Can you explain what that means?
Yeah, so it means that every method declared within an interface is automatically considered public, even if you don't write the public keyword in the declaration. It's like default setting.
Oh, okay. And that makes sense because an interface is defining a contract for other classes to use. So those methods got to be accessible from outside the interface, right?
Right. And it's different from classes where if you don't specify an access modifier, the method is like package private by default.
Ah, right. So when a class implements an interface, it has to use the public keyword when it provides the actual code for the interface methods.
You got it. Otherwise, you'd be trying to make the method less accessible than the interface contract says it should be, and the compiler would complain.
Yeah, that would be a problem. All right, let's move on to how interfaces play with inheritance.
Ooh, inheritance. The family ties of the programming world.
Now, our source mentioned that interfaces support multiple inheritance. And I know that's something that has limitations with regular classes in Java, right?
Yeah, you're right. In Java, a class can only inherit directly from one other class. That's the single inheritance rule for classes. But interfaces, they offer a way to do a kind of multiple inheritance of type.
Multiple inheritance of type. So a class can implement multiple interfaces.
Exactly. It's important to note that it's multiple inheritance of the contract, of the type. The class is basically agreeing to behave in certain ways defined by those multiple interfaces.
So it's like a class promising to fulfill the obligations set out by multiple interfaces.
You got it. Think of it as a class agreeing to follow multiple sets of rules. Each interface lays out a set of capabilities, those abstract methods, and the class implementing them has to provide the actual code to make all those methods work, every single one.
Okay, so multiple inheritance of type. Got it. But there are a few different keywords involved here, right? Like extends and implements. Can you break those down again?
Of course, it depends on whether we're talking about classes or interfaces. When a class inherits from another class, that's when we use the extends keyword.
Okay, extends for classes.
Right. And when an interface inherits from another interface, yeah, interfaces can inherit too. We also use extends.
Okay, extends for both class to class and interface to interface inheritance.
You got it. But when a class inherits from an interface, meaning it's going to implement the interface's contract, then we use implements.
All right, so implements is specifically for class to interface inheritance.
Precisely.
Now, our source specifically mentioned that a class cannot extend an interface. Why is that?
Good question. It comes down to the fundamental nature of classes and interfaces. Classes, they're all about providing that concrete implementation, the how. Interfaces, on the other hand, are more about defining the contract, the what, without the actual code.
The blueprint.
Exactly. So it wouldn't make much sense for a class, which is all about concrete implementation, to inherit a bunch of unimplemented methods from an interface.
Right. So the relationship is more about a class fulfilling the promises of an interface, not directly inheriting code from it.
That's a good way to put it. Hence, the implements keyword.
Okay, so interfaces can build upon other interfaces using extends, creating a hierarchy of blueprints, and then classes come along and implement those blueprints using implements.
It's a beautiful system, really.
Now, we've talked about creating interfaces and classes that implement them. What about creating actual instances, objects of interfaces? Can we do that?
Ah, that's an important point. You can't directly create an object of an interface.
We can't. What do you mean?
You can't use the new keyword with an interface name to create an object. It won't work.
Oh, okay. Why not? We can do that with classes, right?
But remember, an interface is like a blueprint. It's not the actual thing. It defines the contract, the what, but not the concrete how. You need a class for that.
Right, right. So you can only create objects of classes that actually implement the interface and provide the code to make those methods work.
That's the key.
So no direct interface objects. But our source did mention that we can create an object reference variable of an interface type. Now that sounds a bit confusing.
It might sound a bit strange at first, but it's actually a really cool feature. And it's central to this whole idea of polymorphism and abstraction in Java.
Oh.
So while you can't create an object of an interface directly, you can create a variable whose type is an interface. And this variable can hold a reference to an object of any class that implements that interface.
Wait, so the interface variable can point to different types of objects?
As long as those objects belong to classes that implement that specific interface, yes.
Okay, I think I'm starting to see this. It's like a general placeholder that can point to any object that's promised to fulfill the interface's contract.
That's a perfect way to think about it.
Okay, so interface types for variables, but the actual object creation happens through the classes.
You got it. Now, this brings up a question that our source anticipated. Why even bother with abstract methods in an interface if we have to implement them in a separate class anyway?
Yeah, why not just define those methods in the class directly?
Excellent question.
Yeah.
This gets to the heart of why interfaces are so valuable in software development. Think about it. When you start building a system, you usually begin by figuring out the requirements.
Right, what the system needs to do.
Exactly. And those whats, they can be expressed as abstract methods in an interface. At that early stage, you might not know exactly how those functionalities will be implemented.
So you're focusing on the what first, not the how.
Exactly. And interfaces let you do that really clearly.
So the interface is like a way to nail down the essential behaviors without getting bogged down in the implementation details too early on.
Precisely. And different teams or even different parts of the system can agree on what those functionalities should be without being locked into a specific way of doing things.
And that's where the implementing classes come in, right? They each provide their own specific ways of making those methods work.
Exactly. It's all about flexibility and modularity. The interface sets the rules, but the classes have the freedom to implement those rules in different ways.
It's like a universal adapter that can connect different types of devices, even if they work completely differently on the inside.
Perfect analogy.
Mm-hmm.
Now, to really see the power of interfaces, let's talk about how a single class can implement multiple interfaces.
Right, that multiple inheritance of type we were talking about earlier. Our source had a simple example with two interfaces, I1 and I2.
Right. Let's say I1 has a method called methodOwn, and I2 has a method called method2.
Okay.
A class, let's call it concrete class, can implement both of those interfaces.
How does it do that?
It uses the implements keyword
Yeah.
followed by the names of the interfaces separated by commas. So it would look like this. Concrete class implements I1, I2.
Concrete class implements I1, I2.
Got it. And what does that mean for concrete class? What does it have to do? It means concrete class is now obligated to provide a concrete implementation for all the abstract methods declared in both I1 and I2. So both methodOwn and method2. It's got to fulfill all the promises made by both interfaces.
No cutting corners.
Nope. Now, what if a class also wants to inherit from another class and implement multiple interfaces?
Can it do that?
Oh, yeah, absolutely.
Yeah.
Java lets a class extend one and only one other class, but it can implement as many interfaces as it wants at the same time. The rule is the extends part comes first, then the implements part, listing all the interfaces.
So it's like Class my class extends, base class implements interface A, interface B, interface C, and so on.
You got it. Single class inheritance plus the ability to follow the rules of multiple interfaces, the best of both worlds. Our source even mentioned hybrid inheritance. That's what we call this combination of single class extension and implementing multiple interfaces.
Hybrid inheritance. Clever name.
It's a way to get the benefits of both inheritance mechanisms without running into the problems that come with multiple class inheritance.
Okay, so we've got a pretty good grasp on what interfaces are and how they work. But our source also emphasized the importance of comparing interfaces to abstract classes.
Oh yeah, that's a crucial distinction.
So can we dive into that a bit? What are some of the key differences between interfaces and abstract classes?
Let's do it. So both abstract classes and interfaces, they're tools for abstraction in Java. But there's some fundamental differences that make interfaces often a better choice for achieving a higher level of data abstraction and flexibility.
Higher level, okay.
Yeah. First, let's look at methods. We know interfaces mainly have abstract methods, plus default and static methods since Java 8. What about abstract classes?
Well, they can have abstract methods, but they can also have concrete methods, right? Methods with actual code in them.
You got it. An abstract class can provide some default behavior in those concrete methods.
Right.
But interfaces, they're really focused on defining what needs to be done, leaving the how entirely up to the classes that implement them.
So interfaces are more about defining the contract, the blueprint, while abstract classes can actually provide some of the implementation as well.
Exactly. And that's part of why interfaces are considered to offer a higher level of abstraction.
Okay, that makes sense. What about multiple inheritance? We know interfaces are all about that. How do abstract classes handle that?
Abstract classes, they don't do direct multiple inheritance of behavior. A class can only extend one abstract class.
Just one.
Yep. An
Yep.
abstract class can implement multiple interfaces, but a class can't inherit directly from two different abstract classes. That's a big plus for interfaces when you need a class to conform to multiple different sets of rules.
Right, like those multiple hats we were talking about. Okay, what about variables? Interfaces can only have those final and static variables, right?
Yep, only constants.
What about abstract classes?
Abstract classes are much more flexible with variables. They can have variables of any type, final, non-final, static, non-static. The whole shebang.
So they can hold data that can change?
Exactly. Interfaces, they stick to constants, reinforcing their role as blueprints of behavior, not data containers.
Okay. Now, our source mentioned something interesting. An abstract class can implement an interface, but an interface cannot implement an abstract class. Why is that?
It comes down to what they fundamentally are. An abstract class, it's closer to a concrete class,
Yeah.
so it can have concrete methods. It makes sense for it to implement interface methods.
Okay.
But an interface, it mainly defines unimplemented methods. It can't provide the code to implement an abstract method in a class. That's the class's job, or its subclasses.
Makes sense. So keywords for declaring them?
That's easy. Abstract class for an abstract class and interface for an interface.
Straightforward. In inheritance, we use extends for class to class, including abstract classes, and interface to interface. Implements for class to interface.
You got it. And just to be super clear, an abstract class can implement an interface.
Oh, yeah.
It might even provide the code for some of the interface methods while leaving others abstract for its subclasses to handle.
Okay, cool. Last thing, access modifiers. We know interface methods are always public. Abstract classes, are they restricted like that?
Nope, abstract classes are much more open. They can use all the standard access modifiers, private, protected, public, and the default one.
So much freedom.
Right. Interfaces are all about that public contract for others to follow.
Okay, so just to sum up, to declare an abstract class, it's abstract class followed by the class name, and you use the abstract keyword for methods you want to leave unimplemented.
Yep.
And for an interface, it's interface followed by the name, and the methods are implicitly abstract.
Exactly. No body, just a semicolon.
So in the end, both abstract classes and interfaces are important. But interfaces offer that pure form of abstraction. They focus on the contract, the blueprint, without getting into the nitty-gritty of implementation details or storing changeable data.
Right. They're like the ultimate what, leaving the how completely open.
And they've got that awesome multiple inheritance ability. Abstract classes are more flexible with implementation and data, but they're stuck with single inheritance.
Horses for courses, as they say.
It's clear why our source suggested that interfaces are often the go-to choice when you want those clear contracts and maximum flexibility in your system design.
Plus, you mentioned earlier how they're used in frameworks like Selenium WebDriver.
Right, and that really hints at their power in real-world applications. Maybe something we should definitely explore in a future deep dive.
I second that.
Okay, so let's wrap up our deep dive on Java interfaces. We covered a lot.
We did. We talked about their main role in data abstraction, how they define contracts for behavior, what kind of members they can have, those abstract methods, default and static methods, the constants.
Right, and we talked about how they support multiple inheritance through implementation and the difference between interface variables and actually creating objects, and of course, that big comparison with abstract
We
classes.
really went deep.
We did. And hopefully, our listeners now have a much clearer understanding of this really important concept in Java.